Hi everyone, this is just a quick update regarding the Vesc based i3 REME drop-in board, which is just a board I'm developing to control the small inverter which is used in the BMW i3 range extender. The current issues I'm having with it are with the 5 volt power supply which sits underneath here. It's possibly because of the layout or just that I'm using ceramic capacitors in the output, and there's maybe insufficient capacitance, I don't know. So what happens is when I power up the board, that 5 volt power supply doesn't always start up, and that means that the microcontroller here is not going to switch on, but all the other power supplies are fine. I also still need to interface the external ADC inside here, which gets the temperatures of the 3 IGBT half bridges as well as the voltage across the main capacitor, which would be your high voltage battery voltage. With the gate drive power supply now fixed, I'll be able to actually work on that, because while I was unable to get power to this, there's actually power supplies in here which need certain signals to work properly. Without that, the ADC cannot be powered up, meaning that I wasn't able to test it. So now that's fixed, I can actually get that done. And that was using an analog electronics solution with a TL494, but it didn't work due to issues with documentation. There's conflicting documentation between manufacturers, so it doesn't really make sense, and I was never able to get the thing to output any signals. So thanks to ChatGPT, I was able to put a program together on this STM32 board which generates the necessary signals and handles the fault signal should a fault arise with the gate drive power supply, which is inside here. This is currently running a test program which just cycles through the 3 phases and generates a 10 kilohertz complementary PWM signal on just each of the phases. It just sort of cycles through them, and I was measuring that with oscilloscope, and all my fault detection logic is sound by the looks of things. There's no errant signals. All the signals look nice and crisp and got good square edges on them, so there doesn't seem to be any issues with the delay between the controller and the output, so that's all looking good. And again, ChatGPT got that program in there right the first time, so that's absolutely brilliant. If you want ChatGPT to do something for you, it's important that you frame the question right. So you've got to basically tell it exactly what the program's got to do step by step. You effectively feed it pseudocode, and then you're very likely to get a very good answer from it. If you just give it, write me a program which just generates a signal on these 3 outputs, it's probably not going to do it that well. You've actually got to tell it what to do, set up the clocks, set up the timers, and then tell me where to place all the code and stuff like that. You've got to be quite detailed. But the reason I've turned to ChatGPT is because the Vesc Discord has effectively gone dead. It takes days to get a reply, if you even do get a reply, and there's just not much support available there to me anymore, sadly. So everything I do with this from now on is probably going to be helped with ChatGPT. Now, I've never shouted and swore at it because obviously I don't want it to come and kill me when it becomes sentient, if that ever happens. I really think AI is an amazing thing when used for productive things like this, when used to create physical, useful stuff, not pure slop which you see all over the internet, like sculptures of Jesus made out of sticks of celery by some kid over in Africa, and everyone typing underneath it "Amen." I just and like all those AI generated voices, videos that are just totally faceless on YouTube as well. I don't approve of that, but for stuff like this, I think it's absolutely brilliant. I'm going to continue using it to help me wherever possible. So yeah, I just need to continue on with writing the program which interfaces with the external ADC on here. Hopefully ChatGPT can manage that, because it's a lot more complex than what I've been doing with these two microcontrollers. And then I've got to get the correct maths equation figured out for reading the phase voltage, because it's not just as simple as a resistor voltage divider. It's actually going through an isolation amplifier, and the input to output is not one-to-one. There's actually a voltage shift across them, and I can't even remember what that was. I did do an actual test where it just did not match up with the data sheet at all. So I don't really believe data sheets much now. If I want a component, then I do my own tests on it and then create my own specifications, because documentation these days is just getting worse and worse. So other than that, just got the resolver to test. That's a resolver IC there. That is very expensive. I think I paid over £10 just for that chip. So this is the most expensive chip in the whole thing. It's a fair bit of money. So I'll get that sorted out. Hopefully it works okay. Vesc does natively support this resolver, so hopefully it'll be fine. But I've got a small motor, I can test that one anyway. So yeah, this project is not, I think maybe for legal reasons I should say that this is not Vesc, it's based on it. Vesc is a sort of, it does have its own products, but it's open source as well. But when you release a product with it, you cannot call it Vesc. I think you have to say it's Vesc based, or you have to call it just something else entirely. So future ideas I still want to stick with is have a memory chip on this which holds the configuration tool. It won't be called Vesc tool, it'll probably have to be called something else, so I'll need to kind of rebrand it somehow, because I think that's the rules. I tried to ask about it, but I got no answer, so if I try to sue me, it's not really my fault. And that'll be going to a USB hub IC, which will then allow, when you plug this into USB, it'll come up as a serial device, plus you'll see the storage where you can access the tool, so it'll be like the configuration tool is bundled physically with this, so you don't have to go trawling around trying to download it for somewhere. So that should make things a heck of a lot easier. Not only that, I'll include the firmware files on that memory, so that say something goes wrong or you want to change the code or whatever, you could just have the source code right there as well. And obviously it'll be all bundled together in a package that's just designed to work, rather than problems with newer versions of tools coming out and then trying to have issues with it not working with the older firmware, stuff like that. Just a sort of set and forget solution. So yeah, I think I've gone on long enough. It's looking good. I've been off my work the last 2 weeks because they give you quite a generous break, but I'm back tomorrow, and yeah, I've quite enjoyed my time off, but thankfully I also enjoy my work as well, so it'll get me back into a normal sort of routine again.